Hey, it's Mr. Lum again, and we're going to be doing some more Chemistry 11, and today we're going to be looking at percent composition. So we should have already done some molar mass, converting moles into grams, and things like that. So what percent composition is looking at a compound, like salt, and finding the percent of the mass that is made by each of the individual components of that molecule. So here's an example right here. I have sodium chloride, NaCl, and how much of the mass of the sample of sodium chloride is sodium and how much is chlorine. So the first step is to take the molar mass of sodium chloride. So the molar mass of sodium chloride is, well, Na is 23 and Cl is 35.5. Okay, so the total mass of sodium chloride is 58.5 grams per mole. Okay, so the next thing is that we're going to have to take a look at how much is sodium. So we know the molar mass of sodium is 23. And so what we're going to go is 23. There's only one sodium, one Na that's present. So it's going to be 23 divided by the total molar mass, which is going to be 58.5. And that gives it as a percentage. So I go 23 divided by 58.5. and I get 0.39. I'm going to times that by 100 to get it as a percentage, and we get 39.3% of sodium chloride is sodium. Okay. Now you can just do some math on this and subtract that from 100 to get the amount of chlorine that's in there, since it's just two things in there, or you could just go the molar mass of chlorine, which is 35.5, divided by 58.5. And then you're going to be timesing it by 100 again. So 35.5 divided by 58.5, and we're getting 60.7% is chlorine. So here we have another one. We have sodium carbonate, and sodium carbonate is a little bit bigger. So again, the first step is to figure out what is the total molar mass of this. So sodium right there is 23, but we have two of them. So 23 plus 23 is 46, plus 1 carbon, and we have 3 oxygens. So oxygen is 16, 16 and 16 is 32, one more 16 is 48. So the total molar mass of this thing is 106. 106 is the total molar mass. When we take sodium now, sodium is 23, but since we have two sodiums, it's actually going to be all the sodium added up together. So it's going to be 46 divided by 106. So this is going to be 43.39. So we're going to round it up to 43.4%. And our carbon is going to be the same thing. It's going to be 12 over 106. And so that's going to be 12 divided by 106 equals, and that's going to be 11.3%. And then finally, our oxygen is 48 over 106. And that gives us 45.28, or in other words, 45.3%. Okay. So that's our percent composition of sodium carbonate. Okay, here's a question that you could also get. What is the percent composition of water in a sample of nickel 2 sulfate heptahydrate? Okay, so I already wrote out the formula for nickel 2 sulfate heptahydrate, and it looks like that right there. So our first step is going to be finding the molar mass of this. So I'm just going to rewrite this out. I'm going to write nickel to sulfate heptahydrate. So nickel is 58.7. Sulfur is 32.1. And so here's where it gets a little, whenever you get like asked like find the molar mass or find the percent composition of water, when you find the molar mass of the oxygens, leave it separate, leave the oxygen that's in the water separate to the oxygen that's in the sulfate. So the sulfate right here is going to be 64, so 16 times 4. Now, the water portion, I'm going to write this in a different color. So water is, well, the oxygen is 16 plus 2 hydrogens, so that makes it 18. So the water has a molar mass of 18, but there are 7 of them, so I got to times that by 7. So 18 times 7 is 126. So I'm going to write 126 in purple, and then we're going to find the total molar mass of this. So 126 plus 64 plus 32.1 plus 58.7, and that gives us a total molar mass of 280.8. Now, it doesn't want to know, the question is just asking what is the percent composition of water. So we don't have to find nickel or any of that kind of stuff. And so we know what the molar mass of the water in there. Since there's 7 of them, the molar mass of water is actually going to be 126. The total molar mass of nickel 2 sulfate heptahydrate is 280.8. We're going to be timesing this by 100 to put into it as a percentage. So 126 divided by 280.8, and that equals 44.87. We're going to round that up to 44.9%. Okay. Here's another question. What is the percent of sulfate in a sample of chromium 3 sulfate? Okay, so first off, we're going to come up with the formula for chromium 3 sulfate. So chromium is, it tells us what the ion charge for chromium is, which is 3+. Sulfate is always SO4 2-. So when I swap and drop, chromium is going to be Cr2 SO4 3 is what the formula for chromium 3 sulfate is. Now, same thing, I'm going to find out what the total molar mass of this thing is. So chromium is 52, so there's 2 chromium, so 52 and 52 is 104. So it's going to be 104 plus. Now, sulfur is 32.1. Oxygen, since there's 4 of them, is 64. So 32.1 plus 64 is 96.1. Now, there are 3 sulfates. So one sulfate has a molar mass of 96.1. So I need to times that by 3 to get the molar mass of sulfate, and that's going to be 288.3. So if we just want to know what the percent composition of the percentage of sulfate in chromium 3 sulfate, again, we take the molar mass of all the sulfates, so there's 3 of them, so that's going to be 288.3, and divide by the total molar mass. including the sulfates. So it's going to be over 392.3. So 288.3 divided by 392.3. And we get 73.49, or we're just going to round it up to 73.5%. Okay, last question. So here it says you have 11.5 grams of ammonium chloride. How many grams of nitrogen is in the sample? So same thing, what we're going to do here is we're going to find the percent composition of nitrogen in ammonium chloride. And then we'll do one last thing at the very, very end. So NH4Cl, we know that from our periodic table that nitrogen has a molar mass of 14. Hydrogen has a molar mass of 1, but since there's 4 of them, there's going to be 4 right there. And chlorine has a molar mass of 35.5. So we add all that stuff together, and we have the total molar mass of 53.5. So that's our total molar mass. Now, we only have one nitrogen that's present. So to find the percent composition of nitrogen, it's going to be 14 over 53.5. And seems like my pen just died. Trying to find a new, there's, this pen works. Okay, so 14 divided by 53.5 equals 26.17. We're going to round that up to 26.2%. Okay, now I'm actually going to, here's what my percent composition of nitrogen is. I'm actually going to put that back into decimal form and say 0.26, and on my calculator I have actually 0.26168. Okay, so this is my percent composition of nitrogen. Now, I want to know how many grams the nitrogen is weighing in a sample of ammonium chloride. So I take this percentage that's now in this decimal form, and I'm going to times that by my total mass, which is 11.5 grams, and that'll equal 3.009 or 3.01 grams of nitrogen. So in an 11.5 gram sample of ammonium chloride, just over 3 of those grams is just nitrogen.